So I labeled the x-axis in terms of pi over 2 and the y-axis in terms of 1 in order to make the most accurate transformations, as in the original sine graph, the period is 2 pi and the amplitude is 1, making this the best way to make transformations. And with this in mind, I made the value of b equal to 1/2 because once factored, it would allude to a horizontal stretch of 2, and the graph in the picture does appear to be stretched. And from this I made the value of c equal to 7 pi over 4, as the graph appears to be shifted 7 pi over 2 to the left, and once this 1/2 is factored out, then this value, translation will become 7 pi over 2. And finally, it appears to be stretched vertically more than it is horizontally, so I made a equal to 6 and d equal to 7, as the graph is lifted above the x-axis and above at a point of 1. Now for part B, I used the graph of tangent, as the original graph of sine has its extrema at the x-intercepts of cosine, making these values of the extrema of cosine equal to 0, and since tangent is equal to sine over cosine, at these points is when the asymptotes would be occurring. Now for the domain, because it is tangent, we know that it's all real numbers except for the asymptotes, and we find the asymptotes by transforming the asymptotes of the original parent tangent graph, which ends up getting us negative pi over 2. And we know that then that the asymptotes will be every negative pi over 2 plus 2 pi k, or the number of periods away we are moving. And for the range, we know that it is from negative infinity to infinity because tangent goes up and down forever. Now for the y-intercept, we simply plug in 0 for x, and then we use tangent in order to find this intercept at 0, 1. And then for the zeros, we simply plug in 0 for the y value, and then solve until we just have this tangent value on the right. And then we use inverse tangent to find the 0 of negative 12.72, and then we know that the zeros are then negative 12.72 plus 2 pi k, or the number of periods away we are moving.